The 21st century has ushered in an era of unprecedented technological advancement. We are witnessing a transformation that is reshaping the very fabric of our society. Artificial intelligence, or AI, is rapidly changing the world as we know it. This technology is not just a futuristic concept. It is already here, influencing various aspects of our daily lives. From self-driving cars that navigate our streets with precision, to personalized medicine that tailors treatments to individual patients, AI is revolutionizing industries and transforming our lives in ways we never imagined possible. One area where AI is making significant strides is in predicting the lifespan of metals. This development is poised to revolutionize industries reliant on material durability, such as aerospace, construction, and automotive sectors. By accurately forecasting when a metal might fail, AI helps in preventing catastrophic failures, ensuring safety, and optimizing maintenance schedules. Metals are the backbone of our modern world. From towering skyscrapers to intricate aircraft, we rely on the strength and durability of metals in countless applications. However, even the strongest metals are susceptible to fatigue, a process of weakening and cracking under repeated stress. Metal fatigue can lead to catastrophic failures, resulting in accidents, costly repairs, and even loss of life. Traditionally, predicting metal fatigue has been a complex and imprecise science. Engineers relied on a combination of physical testing, historical data, and safety margins to estimate the lifespan of metal components. However, AI is changing the game. By leveraging the power of machine learning, AI algorithms can now analyze vast amounts of data to predict metal fatigue with remarkable accuracy. Section 4. Real-world applications: AI in action. The applications of AI in predicting metal lifespan are vast and varied. In industrial settings, AI systems are employed to monitor and analyze the wear and tear of metal components. This predictive capability allows for timely maintenance and replacement, thereby preventing unexpected failures and extending the operational life of machinery. By leveraging machine learning algorithms, these AI systems can process vast amounts of data to identify patterns and predict future performance with remarkable accuracy. In the aerospace industry, AI is used to predict the fatigue life of aircraft components, improving safety and reducing maintenance costs. AI